we like to do is lift up the females in the community. Fortunately, over the course of my being a software engineer, I have seen the number of women increase hugely, and it's been amazing for me. And yeah, I love that this actually exists. And I still actually remember the first time I came to a ReactJS Girls event. It was about 4 or 5 years ago now, and I was fresh out of boot camp. I didn't really know if I was going to fit into the tech community, and I found this community, and I realized, watching 3 women on stage speaking, that I wasn't just going to fit in, but I was going to be in this community, that I actually was part of it. And it really changed things for me. So yeah, I'm excited to be now the one on the other side of the stage. So quick talk about the agenda. So obviously the intro is happening now. You've made it. Then we have a few quick words from our incredible sponsors, which include my own company, as well as the wonderful Monzo, who have made all of this happen. And then we'll have our first 2 talks immediately after that. Then there'll be a 20-minute break. You can have some more sandwiches, have another drink, have a few more drinks if you want. Obviously go to the loo. And then we'll be straight back here for the final talk. And then above all else, the Q&A, which is going to be something which you can contribute to right from the start. But I'll talk about that in a sec. And then when we wrap up, we've got like a tight deadline, so we need to be out of here by 9. But when we wrap up, we're going to go straight to the Horse and Groom, which is just a 1-minute walk away. So it's an achievable pub wander. Who doesn't love a pub crawl? So the exciting bit, the evening's topics. First, we've got Elle Townsend, who's going to be putting the U in user experience, followed by Stephanie Shaw on server components, which is a super exciting hot topic. And then after the break, we have a love letter to long lines, and other DX stories. Beautifully alliterative title. Some brief logistics. Code of conduct. Our code of conduct is basically be nice. I'm sure you'll all abide by that. It's generally good life advice. And if you have questions for the speakers, remember them all, basically, because the Q&A is not immediately after the talk, it's after all of the talks. And it's good if you remember who they're for, so that you can direct your question at them, either in person, or we have a piece of technology called Slido, which is accessible at any point on one of these QR codes. So if you scan the QR code, I think it's on the next slide, here we go, the QR code to rule them all. On there is not just the Slido deck, where you can add your questions and upvote other people's questions that you think are maybe better than the ones you were going to think of. But you can also, check out additional information about the speakers, and find out more about YLD. There's a host of other things on there. So scan the QR code. Can you all see it? It's not like too small, yeah? Okay, amazing. Exciting. So that didn't take as long as I was worried it might. So yeah, one more thing, the socials, social media. If you are on Twitter or X, the artist formerly known as Twitter, then you can use the hashtag ReactJS Girls, appropriately enough, and follow us at ReactJS Girls. And I think that's also on the QR code, so scan that QR code. And now just a few quick words from our sponsors. So first, we've got Alex from YLD, who's going to introduce, say a few things about what we do.
Hello, welcome to ReactJS Girls, number 5. So I'm Alex, I'm one of the talent partners here, and I'm just going to let you know a little bit about who YLD are and what we do. So we are a software engineering and design consultancy. We've been rapidly going for the last 10 years. It's actually our 10-year anniversary this year, so a massive milestone for us, which is amazing. So we work with various different companies across the globe, from healthcare to renewable energy to fintech, and the list goes on and on, and you can actually see some of them here. The way that we work with our clients as well is not to just build great products, but also to work with them and help them grow and leave them in a better place than when we found them as well. So that's taking on that consultative approach and being the experts that we are. So with that as well, with me being in talent, it'll be silly not to say that we are looking for talented individuals to come and join us. Majority are within kind of the full stack, JavaScript and ReactJS Girls, one of the reasons why we're here as well. But feel free to come and grab me or anyone in a YLD t-shirt. And yeah, if you're wanting to have a new challenge, then come and join us. But yeah, enjoy the evening.
And then next, a few words from Monzo, from Tom at Monzo. Thank you.
Hi everyone, so just some housekeeping rules, okay? So you got the fire exits on the side there and on that side. Toilets for those who haven't been already, it's on that side there. Please, I just ask you not to leave with any alcoholic drinks, okay, from the premises, please, okay? If you're non-alcoholic, that's fine, you can live with it. Other things, we are not really hiring right now, but that's okay. You can still come and talk to us. So you can come to talk to myself, you got Harriet, and you got Alex over there, so Harriet is there. We might be hiring for web engineers in the next, 3 to 6 months, so if you want to have a chat and learn more about what we do, probably not going to tell you more about what we do, you probably already know a little bit with bank. And yeah, if you want to connect a different way, we've got QR codes next to the fridges, so it's a strategic position. You can just scan that and register an interest and then have a chat, a low-key chat, if you want with us. Okay? Enjoy the evening. Thank you.
Let's get on with the talks. It's time for the good stuff. So our first speaker is Elle Townsend, who is fluent not only in English, but also in JavaScript, also Korean, and is currently learning French. So, a woman of many talents.
I can't read zeros and ones. That's not a good start. Hi, everyone. I'm Elle Townsend. I'm a web engineer here at Monzo, and I'm here to talk to you about putting the you as in you web engineers, in user experience. So whether you like it or not, user experience design and user experience in general plays a really critical role in shaping how users experience online websites. I want to look into today about how user experience principles can be integrated into the web development process to create websites that not only look nice, but also feel nice and provide really nice user experiences. I'm going to talk about some fundamental user experience principles and how they can then be applied in web development. I'm going to show some examples of little bits of user experience in terms of web and how we can harness these principles effectively in web development. So yeah, that's me. I'm Elle. I work at Monzo and I have a website and Monzo.com. Yeah, that's what I work on. So user experience principles they're not like rules, you can break them, they are just principles. They can be adapted and expanded with combinations of things like user experience research, questionnaires, all sorts of different approaches you can take to help create the best possible experience for web users. These are 4 different principles, groups of principles that I picked out and that I want to talk about today. And the first one is heuristics. So heuristics means enabling a person to discover or learn something for themselves. So it's all about helping people make decisions and discover things on their own. And most of these principles were kind of initially developed, I guess, in the 1990s, so a bit over a while ago. Fundamental principles kind of does what it says on the tin. They are the fundamentals, just fundamental ideas. not really much else to say on those. Gestalt principles are actually, is a German word that means an organized whole that is perceived as more than the sum of its parts. So these are principles of visual perception, and they are all about how humans gain understanding from different stimuli and making sense of visual information. And these principles were actually kind of developed in the 1920s by German psychologists. And then finally, we have cognitive biases. So these are more about decision-making and interpreting information. So how users perceive and interpret and interact with digital interfaces, and understanding how these cognitive biases can impact the way that people do that. And I'm going to take you through each one of these, and I'm going to have one example of each one. The first one being the aesthetic usability effect. This is a heuristic principle, and it was created or founded, I guess, in 1995 by some researchers at Hitachi. They were actually looking into ATM UIs, and they were looking at how aesthetics, how nice the interface looked, impacted perception of use. So it was all about how did it look and how easy was it to use. And there was actually a strong correlation found between aesthetics and aesthetic appeal and the perceived ease of use. So it wasn't even about how easy it was to use, it was how easy it looked like it was to use. So nice looking designs are really important, and they can sway how functional your users think your website is. So here's kind of a small little example I've mocked up of something along these lines. Functionally, but they both do the same thing, but one of them has a bit of an aesthetic sprinkle on it, looks a bit nicer, and potentially could be perceived to be easier to use by users. Users tend to enjoy aesthetically pleasing designs, and who can blame them? We all like shiny, fancy things. So making nice, visually appealing designs can actually make up for a bit of a lack of functionality. Not completely, you can't do nothing and make it look nice, but nice looking designs can go a long way. In doing that, negative space is really important. Having cluttered screens is not very easily readable for users, and it also takes users' focus away from what they're trying to do. So using white space is really important as part of this principle. And also being consistent. Maintaining uniformity in your designs helps with predictability, so your users can become familiar with how your site works and reduce their cognitive load in trying to do what they want to do on your website. So yeah, making your website look nice is really important. The Doherty threshold is a fundamental principle of user experience, and this is all about productivity, essentially. It was founded by a study done by IBM in the 1970s. All of these principles are kind of a bit old, but we still use them today, that's fine. But this one states that response times for interactive computer systems should be kept below 400 milliseconds, or 4 seconds, to maintain the user's flow of thought. So this is all about optimizing the performance and perceived responsiveness of your websites to keep your users engaged. This is an example of how you might like to do that. Instead of just showing a little thing that goes around while your page is loading, you could have a little progress bar, or it doesn't show up very well on this screen, but like a skeleton screen that has kind of grayed out area where content's supposed to go when it loads. So in order to implement this in web development, you can play with the perception of your users. So yes, optimization is important, speedy websites, all of that good stuff. but you can do a lot with the perception of responsiveness to help you out. So reducing perceived wait times, like with things like skeleton loading screens and progress bars, can help that user experience, as well as actually adding a little bit of delay. It has been found that if you put a little bit of delay into some of your things, they can actually feel a little bit more trustworthy. I don't know if you've ever paid for something online and it just goes by too quickly and you're like, wait, did I actually pay for that? Like, you go in your bank and check. So yeah, adding a little bit of delay can also help you out. But it is important to remember that 400 milliseconds back in the 1970s was loading a text-based document with no CSS, no JavaScript, no nothing. So you have to take it with a pinch of salt there, that your web page might not get to that crisp number. The law of similarity is a Gestalt principle which explains how humans perceive and organize visual information. So this is all about when users are looking at a group of objects, they tend to perceive things with similar characteristics to be related. So in this example, we've got a couple of buttons on this menu, and the difference here being that if the two buttons are the same color and they look exactly the same, your users might get a little bit confused and be like, well, what, does the delete button do that? And so it's all about kind of being consistent and playing with similarity to your advantage for all of that sort of good stuff. Using your buttons and styling to kind of create familiarity across your site. This also includes stuff like borrowing design patterns from other places, the things like the save icon, all of that good stuff. Using things that your users would already be familiar with. You can make use of that in your web design, and that will help users more easily become familiar with your site in the way that your site does things. Again, consistency. If your delete button always looks a certain way, make sure it always looks a certain way so that users can find it. But when you have a lot of similarity across your website, being distinct can also be a benefit. So if you want to really draw a user's attention to something, if it stands out from the similarity, your users' eyes are going to be drawn to it. And the next one is the peak end rule. So this is a cognitive bias, and this one is actually all about how people tend to judge experiences. So users, or people in general, I guess, actually tend to judge an experience, and they judge the experience overall by the most emotionally intense point, which is in this rule called the peak, and then how the event ends. So like if you go to the cinema and watch a film and then you tell someone about it afterwards, you're probably going to talk to them about the most intense part, the twist, the bit that really got you, and how the film ended. They're the two bits that are going to sway you the most, and the same goes for experiences on the web too. So, for example, because these moments in your users' time throughout your site have a disproportionate effect on how users perceive that this experience is going to go, you need to make sure as a web developer that these key touch points are nice and delightful. So we want to minimize the negative peaks. We want to reduce the impact of that highly emotional moment if it's negative, with things like getting rid of error messages that aren't very helpful, or making sure that the user knows what's going on if something's gone wrong. And then also bringing delight into the final moments of a process, like a nice, satisfying sign-up screen, for example. We really, in this principle, it's all about having a good impression, making sure that things flow smoothly, and when they don't, making sure that you're mitigating for that and still helping your user have a good experience. Again, optimizing, when things take ages to load, that's a bad experience, and that might sway how your user judges the entire process as a whole. And adding nice little delightful things like satisfying animations, personalized touches, to make your site just feel good for your users. So that's been kind of 4 different points from 4 different user experience principles. So to summarize, these principles are not just about creating pretty pages. They're about creating meaningful and enjoyable experiences for people that are using your website. We need to make sure that we put the users at the heart of web development, understand their needs, what they want from this experience that they're getting on your website, and what their pain points might be when they're doing that. And we can do that by things like embracing simplicity, helping your users find what they want to find on your site without getting lost, remembering the need for speed. Your users don't want to wait around, so having nice, speedy web page loads is always a good thing, but you can also play with the perception of that speed to various effects. As well, consistency is really important. I know I've mentioned that a few times now already, but consistency breeds familiarity and therefore trust. So keeping your design elements and interactions consistent will help your users become familiar with your site and trust what your site is trying to help them with. And finally, please try to sprinkle some delight into your web pages. Your users want to be charmed, they want to have nice, fun experiences, and whatever you can do to help that would be amazing. We can improve the web one delightful click at a time. I spoke really quickly, but thank you so much for listening. That's me.
All right, folks, are you ready for a server-side revolution? All right, so I'll just quickly take you through the agenda. We're going to start off with a quick bit of context, a brief history of websites. We'll talk a bit about server-side rendering and why that's not React server components. And then we'll finally see the real React server components, not quite a demo, but some, we'll get to see what it's all about. But we'll start at the beginning. And when I say the beginning, I mean the very beginning. In the beginning, when Tim Berners-Lee created the World Wide Web, the internet was a formless void and darkness covered the face of the deep. And then Tim said, "Let there be HTML." And there was the first website. And here it is, the very first website that launched on the 6th of August, 1991. And it's still available to view on the CERN website if you're interested. As you can see, you'll have learned from Elle's talk that this is not very aesthetic. It's just some HTML with some text and some links. But let's have a look under the hood, shall we? And as we can see here, this is open in the dev tools, and the only resource that we've downloaded on this website is a single static HTML page, the project.html. And because of that, the Lighthouse performance analytics show that the performance is phenomenal. There's a lot to be said about the performance benefits of static HTML. And you remember that one for later, it will become useful. Let's skip ahead 15 years to the year 2005. So I wish I had time to talk to you about GeoCities and the .com bubble, but we're going to get to serious internet business here. I think 2005, most organizations realized that the internet is going to become a core part of their business or organization in the future. The BBC was an early adopter of the World Wide Web, and they started off existence as one of the world's most reliable sources of information on the radio, and they wanted to be one of the world's most reliable sources of information on the web as well. And we can see from their archive, they have a fantastic archive of old school pages, and here we've got one from 2005, and it's a lot more visually engaging than the old CERN website. You can see it's got some colours, it's got that nice BBC branding, so we know that we can trust this news source. It's got some pictures, a bit of CSS, and a few interactive features, such as being able to click the live play button to view the BBC News channel live. And in order to add all of this really cool functionality, well, we need to download more resources. That would be CSS for the styling. We've added some images and content, and also, of course, JavaScript. And because we've added this JavaScript, we can see the performance has taken a slight hit. It's now scoring a 93, which is still very respectable, around 1.2 seconds for the first content to appear on the page, slightly slower than that 400 milliseconds, but user will be twiddling their thumbs for 1 second and then they'll get the news of the day, which is pretty cool in 2005. So still pretty good. And let's skip ahead another 15 years, and we get to the present day, 2023, sorry. And nowadays we use the internet for like pretty much everything, right? And you can do so much. Like just take LinkedIn as an example. I could see a feed of content that's directly tailored towards my specific interests and that of my network. I can see jobs that I could apply for. It would even nowadays tell me what skills I'm potentially missing from those jobs, contacts that I know from my network that could give me a good word. I could reach out to hiring managers directly. I can see, learn new skills on LinkedIn Learning. There's so much I can do. But that comes at a cost. And the cost is the performance. And we can see that the Lighthouse Performance Analytics show that it's got a score of 65, which is not good compared to the good old days of CERN, right? We can see that the first content will pay is 0.6 seconds. That's pretty good. So we see something on the screen, probably a loading spinner, but the time that it takes for the page to become interactive, so when I can use it, that's 3 seconds, and that's quite a long time. And the reason why it takes so long is if you have a look at my GIF there, you can see at how much content is downloaded just to render that page. There's several bundles of JavaScript. They're all incredibly long, lots of content as well, like images, lots of styling as well. And yeah, it makes it a little bit slow, unfortunately. I just picked LinkedIn as a random example. I'm not picking on them. It's quite indicative of the performance of web pages today. And yeah, I think even big tech names as well, will have a similar sort of setup to this. And let's have a look at my very scientific scale for ranking website chunkiness. So we can see that back in the day, our static HTML websites are as agile as a lean cat. And gradually, over the past 30 years, we're getting up into this mega chunker category. And if it continues on this trajectory, oh Lord, he coming. But what's actually changed over the past 15 years that's caused this website obesity pandemic? The answer, of course, is JavaScript single-page application frameworks, such as our old friend React. We call it SPAs for short. And SPAs were introduced in around the year 2010 with early frameworks such as Backbone, AngularJS, Knockout.js. And in 2013, we got React, 2014, Vue.js. And as they've become more popular, it's now the go-to choice for pretty much most web developers out there creating websites today, which is why we see those performance issues in even big name tech websites. And the reason why SPAs are so popular is because users love interactive websites. As we saw through the brief history, the CERN website was very boring and a bit weird to look at for us, but we want that functionality that LinkedIn gives us, where I can just do pretty much anything that I can dream of, things that I couldn't even imagine in the year 1991. But the downside of that is it requires us to to download much larger bundles of resources over the network. And the reason why that's a problem is that as the internet's landing in the pockets of more and more people around the world, especially in the developing world, such as in Africa and South Asia, we can't just expect everybody to have a 5G interconnect connection and an unlimited data plan and a top-end device. And I'm sure everyone's had this experience where you go on a website and it just takes ages to load. It's man, I don't have time to wait 5 seconds. I'm going to go to another website. I don't have time for this. And that's just imagine how it is if you're accessing, a website, a big website like LinkedIn on a 3G connection with a smartphone from the year 2010. It's probably excruciating. And there's been a lot of studies into this very effect. And Walmart did a study which showed that on their website, that for every 1 second improvement they made in page load time, the number of conversions, that is the amount of people who visited their website who then went on to buy a product from their website, increased by 2%. And you might be thinking, 2%, that's not very big. But if you think about the scale of Walmart's business, the high volumes that they're doing, 2% actually is a value of hundreds of millions of dollars per year. And that is incredible. It's man, I want to, and that's just 1 second improvement in the performance of their website. And you're I want to get on I want to give this millions of dollars. But do we just go back to using static HTML for everything, right? Return to monkey, the Stone Age, right? Or is there another way? Is there a middle ground? Yes, there is a middle ground. The middle ground is server-side rendering. So server-side rendering isn't a new concept. It's been around since the pretty early days of the web. Frameworks such as PHP and Rails use server-side rendering. But what has come around more recently with products such as Next.js, Quasar, and Gatsby is that we're bringing server-side rendering to our modern JavaScript SPA frameworks, and that has helped companies like Walmart, for example, make these huge gains in the performance of their websites and delivered real value to their companies. But to understand what server-side rendering is, it's good to, we'll have a look first at what client-side rendering is, which is how React and other similar SPA frameworks work today. So when we go and navigate to a URL, the first thing that will happen is it will make a request to the server to download some resources such as the CSS, the JavaScript. That will get downloaded to your browser. The browser will then execute the JavaScript. That JavaScript will contain React. React will then do its thing. And now you have a page that's viewable and interactive. But until that time, you can see here that all you can see is a loading spinner or a loading bar. And it's like, I don't get to do anything. That's, if we're talking about 3 seconds until I can see the page, that's, 3 seconds that might result in your customer thinking, well, this is a bit naff, right? And the difference with server-side rendering is that what we do, when we send that initial request to the server via our URL, it's able to send down some static HTML immediately. And we know that static HTML is lightning fast. And that means that from the very second stage here, before we've downloaded our JavaScript bundles, we can actually see something as a user on the page. That might just be a loading skeleton or a loading bar, or it could be a whole page of content that you're able to fetch from the data, from the databases, like from that request, and send down a fully, fledged page with useful content. But it won't be interactive content until you're able to download those JavaScript bundles and execute them on your browser. And so, although we are able to see the page at this point, we're not able to interact with the page until the very last stage. And it kind of gets you thinking, like, wouldn't it be great if you could just, rather than waiting until the very last stage to make your page interactive, what if you could send content down a lot faster without actually having to deal with the JavaScript downloading step? And that is exactly what React Server Components tries to solve. And it does that by streaming React components that we know into a JSON-like format over a standard streaming protocol such as HTTP2. And then when it hits the browser, it's able to, the React DOM is able to interpret that into a regular React component and then run reconciliation cycles to update that, and you're able to see some content without actually downloading any JavaScript at all. It's like magic. And you might guess from the name server components that it does need a server to work. And this isn't a replacement for server-side rendering. And indeed, team at React have been working very closely with most of the popular frameworks such as Next.js to ensure that React Server Components is included and treated as a first-class citizen within server-side rendering frameworks. Indeed, Next.js 13 also includes React Server Components by default if you enable their experimental features, which is really cool. And you might be thinking, man, 0 bundle size. Let's do that for everything. Let's just do it. But there's some cases where you can't use server components. So we'll talk about here server components versus client components. So for server components, they're really great for if you want to fetch data or access backend resources. And the reason for that is usually, as we saw in our client-side rendering diagram earlier, when you make a request to a URL, you go to the server, request some stuff, it sends down the bundles, and then the bundles execute, and now it's like, now go back to the server and fetch me some data, right? And you're going back and forth and back and forth. And while you're doing that, you kind of might be stepping over firewalls and whatnot. It's just quite slow. But if you're able to get all of the data you need while you're on the server, it's much faster for resources on the server to interact with each other. And so you're able to make some great gains in your performance that way. Another great use case for server components is if you want to access secure information such as secrets. So imagine you have an API key If that gets sent down to your browser, as we all know, if you open DevTools, you could probably find out what the company's API key, and then you could not steal it, but but yeah, I mean, if that's sent down to the browser in the first place, then there's a lot less chance that it will leak out. And the final use case is if you're using a library, like an NPM package that's quite hefty, you don't necessarily want to download that and add it to your bundle size, but if you're able to execute that JavaScript on the server, then you don't have to download it to the browser. And you're like, well, how does that make a difference? So you kind of think about, like, I can scale up my servers to be as performant as I need them to be, but I can't scale up someone's like terrible mobile phone connection or like terrible device, right? And so it makes much more sense to do those heavy computing operations on the server rather than on the browser. And there's some cases where you can't use server components, and that is if you need to use states, use effects or lifecycle hooks. And so that's actually the bit that makes your pages interactive. But there's a way around that. We'll see that later. And the other thing that you can't use it for, obviously, is if you need browser-only APIs. So things such as geolocation or accessing the user's microphone, for example. It just doesn't make sense to do that on the server for hopefully obvious reasons. And the way that you would make something into a server component or a client component is via this directive at the top here, use client. And so if you know that you're creating a component that, say, is using use state, use effect, use transition, well, we know that we can't use that as a server component, and so we can say specifically, okay, this is a client component. Everything else, if you don't specify, will be able to be used as a server component or as a client component. And if you want to make something that's only can be a server component, then you can optionally specify a use server component, a directive at the top. And that's it. It's that easy. That's all you have to do to make use of it. So we can see a bit of server components in action. I wasn't brave enough to do a live demo, so we've got some screenshots, but hopefully we can still have fun with it. The QR code there is to my GitHub repo that I've made. It's a fork of the React team's components, server components demo. But I've added some notations to it to make it a bit easier to understand. And I've also changed a few things around to just make it easier to demonstrate some of the effects. So feel free to have a look at that. There's extra stuff in there that I'm not going to be talking about today because time constraints. But yeah, let's get straight to it. So this is what the demo app looks like. And it's a note-taking app, CRUD app, create notes, read notes. It has an Express and Postgres backend. And the component that we're going to be looking at today is this component here, where in the sidebar we're able to see a preview of a note. It has some content, it has a header, it has this content here, a little snippet of what content is inside the message. And as we can see, it also expands and collapse, which is a bit of interactive functionality. You might be thinking, well, for interactive things, we know that we have to use a use state or something like that, so we can't use server components in this situation. But think again. Right, so that little excerpt there, the bit with the emojis that was popping up earlier, the way that we generate that is we've downloaded an NPM package called excerpts, and we can see from the angry red text, it's a big bundle. We don't want to be downloading that to our browser if we can avoid it. And what we're able to do is, because this is a server component, it will do some magic, essentially. Well, not magic, stream it over the HTTP protocol. And you're able to, there we go, yes. We're able to see, okay, you can expand the notes. And let's have a look at the bundles here. Our component there was called sidebar note excerpt. And you'll notice that it doesn't appear in the downloaded resources, so it's out of thin air. And also in the node modules section, we've not got the excerpt bundle either. And so we're able to use that server component within this interactive website without any bundle size. We've just shaved off a little bit of our bundle size, just doing that. Which, when I saw that, I was like, that is pretty cool. That is pretty cool. And again, we've got a server component here, sidebar notes. So this sidebar note component is for the entire notes, including the header and the content. And it's a server component. And it's a server component that contains this client component. And this client component contains a server component. And so you can mix and match. You're not limited by something being a client component and thinking, oh wow, now because I've had to download this bundle, to the browser, it's going to download everything inside it. Because of the particular streaming format, that the serialization format it uses is similar to JSON, it doesn't let you to have a server component as a direct child of a client component, but there's a bit of a hack around that. You just pass it in as a prop instead. So if your prop has a server component in, that'll work. And we can see here, so our server components in this case will be sidebar notes header, and sidebar note excerpt, and sidebar note content is the client component. And again, looking at our bundle again, we can see that sidebar note content has been downloaded, but the thing that was containing that sidebar note wasn't downloaded. And the thing that was included in sidebar note content, the excerpt, also wasn't included. It's like magic, right? But is it coming out of thin air? No. What it's doing is it's streaming that information directly from the server. It's rendering them on the server, turning them into this JSON format, and then sending that to the browser. And React is able to kind of just interpret that stream without having to download any JavaScript. And this way, we're able to include some of the benefits of server components with our interactivity that we know our users love. Cheers. Wow. All right. And when I heard this, I'm like, yeah, sold it. I'll buy 10 of them, right? No, but it's still an experimental feature, unfortunately. So you can't use it yet, but it's coming really soon. They just won't tell us the date yet. The good news is that compared to December 2020, when they first announced it, we actually have an RFC that's been merged for this now. So they've decided on pretty much all of the architectural features of this, and they're definitely going to do it. We just don't know the date yet. Because it's an experimental feature, they don't recommend using this in production, and that includes on Next.js as well, although it is included in there, as I mentioned before. But you're very welcome to use the demo to explore it. I think that's the way that they recommend getting to know it as well. There's a few extra little bits and pieces that I've included in my repo. You can just search for the word Steph in the repo, and you'll be able to see all of my comments that I've added in there. And if you want to learn more about this, then the RFC that I mentioned is probably the most comprehensive source of this that we have. As I said, it's very new and experimental. But the RFC contains a load of valuable information on how this will all work and some of the finer details as well. When they first introduced this idea, it was back in December 2020, they had a YouTube video, which I've attempted to condense down into 20 minutes. The YouTube video is 60 minutes. And although some of the information is a little bit out of date in that video, it's still a really great introduction. So if you have 60 minutes of time, perhaps if you're waiting for a really bad website to load, then watch the demo, it's fantastic. And then finally, Next.js 13 as well, they have lots of great information about how server components will work in the context of a server-side rendering framework. And so that's... So yeah, thank you so much. I'm Stephanie Shaw. I'm a senior front-end engineer at Beamery. I'll be talking at React Advanced next month, so if you're going to that, do keep an eye out for me. It's been a pleasure. Thank you very much.
Thank you very much.
Thank you. Awesome. Hello, everybody. Thank you so much for coming. I'm Jo Franchetti, and as mentioned, I am a developer advocate at Spotify. I work on the Spotify developer portal. You can get me at This Is Jo Frank on all of the socials, whichever socials we are using these days. And I'd like to talk to you about the importance of developer experience. So let's start with a story to illustrate what some of you may have experienced before. So you're a software developer, and you've been asked to integrate a new developer tool, and we're going to call it Codemajig. Someone at your work has told you that Codemajig has been recommended for its advanced features and its time-saving capabilities, and you're excited about the potential that it offers. So you embark upon the journey of learning what Codemajig can do and how you can onboard with it. And you start with the obvious. You use your favorite search engine to find online tutorials, to find their documentation, to try and understand the basic concepts and functionalities of Codemajig. But you quickly realize that the available learning resources are scarce and they're quite poorly structured. The official documentation is not only incomplete, but it's also outdated. It lacks clear examples, it lacks practical use cases, and you have found some tutorials, but they're either overly simplified or they're way overcomplicated, and they leave you feeling confused and frustrated. But you're determined to overcome this initial setback, so you reach out to the Economist community to ask for assistance, and you join their online forum, you join their Discord, and you hope to find guidance from some experienced users who've used Economist before. But the community turns out to be kind of unresponsive and unwelcoming to newcomers, and your questions just go unanswered for weeks. But you're a consummate professional, so you decide, you know what, I don't need the community, I don't need the documentation, I'm gonna just try it myself. So you decide to experiment with Codemajig, and you start by working on a small project. But you quickly discover that Codemajig has quite a steep learning curve. Its code base is complex, it lacks structure, and it's challenging to navigate. Codemajig lacks proper error handling, there's no test coverage, you're getting cryptic error messages that don't help at all with troubleshooting. You find numerous bugs and inconsistencies in the tool, and you try to report these bugs to their team, and the team just don't respond. They never resolve the issues that you raise. Weeks turn into months, your enthusiasm wanes, and you begin to question why anybody told you to use Codemajig in the first place. Their lack of learning resources, their unhelpful community, their poor user experience, their lack of support, their technical issues just make it impossible to actually use this tool. Ultimately, you and your team decide to abandon Codemajig completely in favor of another tool that offers better documentation, a supportive community, and a shallower learning curve. By Codemajig, you have lost this customer because of your bad developer experience. And I'm sure many of you have had a similar onboarding experience. This first time you use a new tool or a framework or a language is absolutely essential for your development journey and deciding whether or not you're going to continue to use this product. And we want people to use our products. And so we need to be able to sway developers to perceive the quality of our code within our organization as high quality. And developer experience, or DevX as it's often called, describes the journey that a developer is going to take when they're onboarding with your tool and when they're using your code. It's the lived experience of all of us as developers and the points of friction that we encounter as we try and use tools in our everyday work. And developer experience isn't just at the getting started phase, it's all the way through. So it's building, it's testing, it's debugging, and it's releasing products with your code. And as developers, as people who work in tech, as people who are building tools, even if you do manage to make the sale and you get somebody onboarded with the product that you're building, you need a pleasant developer experience to keep them. Otherwise, you are going to lose them the moment that they find a tool that looks better than you're offering. Poor developer experience is going to cost you money, it's going to ruin your customer base and damage your reputation. And a common misconception is that DevX is only affected by the tools and the products themselves, but research shows that there's actually a huge amount of human factors involved, such as having clear goals, feeling psychologically safe, feeling like you're part of a team, or that your project can have an impact on your well-being. So improving DX increases not only the productivity of the developers that are using, but also their satisfaction, their engagement, and it can improve employee retention. So let's take a deeper dive into things that can affect developer experience. So there was a great white paper that was released very recently by the Association for Computing Machinery on developer productivity, and I've linked that down here. I will share the slides out at the end on the socials. It breaks developer experience up into 3 segments. So we've got cognitive load, we've got flow state, and we've got feedback loops. And when we consider all of these 3 together, that's the full range of friction types that you will experience as you work. So let's take a brief look at each of these. I'm sure we are all aware software development can be difficult. It's complex, it's complicated, there are always new tools, new languages, new methodologies to learn. And writing and reading and learning code all contribute to a workload in your brain. This is the cognitive load. And cognitive load refers to how much information you need in order to complete a task. And alongside not only the how much brain power you need to complete a task, but what other stuff is going on in your head at the same time, and how much effort it is going to take to not only understand that knowledge, but to retain it, to actually learn it, to keep that new knowledge in your head. And psychologists often refer to this as something called working memory, which is how much capacity your brain has to hold information. And it works actually very similar to how RAM in your computer works. So we have this certain amount of fast access storage available to us, which we fill up as we're doing tasks. And when that capacity is full, we have to stop doing one task in order to be able to successfully do another task. Otherwise, we find ourselves making mistakes. If you ever tried to do too many things at once and then miss something, drop something, forgotten something, it's because your working memory was full. And cognitive load will increase for your developer if they're working on a difficult or a complex task, or if they're trying to learn something new. And it can also be increased by extraneous information being presented while they're trying to concentrate, trying to multitask, working in a noisy environment, or working somewhere with a lot of visual noise. Things like poor documentation, too much instruction, too little instruction, badly designed tasks or confusing tasks can all increase your cognitive load. And if you're feeling bored, or you're feeling anxious, or you're feeling tired, it can decrease the amount of working memory that you have available, thus increasing your cognitive load. And when cognitive load is high, developers need to put more effort in order to complete a goal. They will likely make more mistakes, and they will have just less innovation in their work. So to improve developer experience, teams and organizations should aim to reduce cognitive load as much as possible by finding ways to eliminate the hurdles that increase cognitive load. So we should be creating well-organized code bases. We should be writing good, thorough documentation. We should be making sure that if we're helping somebody to onboard, we are setting well-defined tasks and goals that allow them to feel a sense of achievement, to give a clear objective so that they know what they're working towards. We should be, as much as possible, reducing the amount of context switching that they need to do. And if you have a dedicated DevX team, they should be providing easy-to-use, self-service tools that help developers to streamline the steps that are required for them to onboard, start using the tool, and be successful with it. And this isn't only about building external tools for external developers. This covers the developer experience of working with your own code bases that you're writing as well. Presenting information in different styles and methods can also help by making learning accessible to people who learn in different ways. I personally prefer to learn by doing, so I love demos and tutorials. Some people like to learn by watching videos, some people prefer to learn by reading. So give a whole load of different ways of displaying that information. Allow developers to use tools that will aid their own cognition. Because when cognitive load is well managed, developers will find it much easier to be efficient, effective, to be productive. And it allows for this thing called flow state to happen. And I'm sure you've all heard people talk about like, oh, I was really in the zone today, or oh, my flow was interrupted because I had to have a meeting. And this idea of being in the zone is what we call flow state. And flow state is a mental disposition in which a person becomes fully immersed in the activity that they're trying to do. And it's an enjoyable, it's an energizing feeling. You feel like you're being more creative, more innovative. You're motivated, you're highly efficient. You feel like an enhanced individual when you're in flow state. And it can make learning easier, it can make us more productive, it can even make repetitive tasks actually feel quite gratifying when we're in a flow state, 'cause we're like, done, 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 yeah. And this feeling of enjoyment can lead to developers performing better and producing higher quality products and just being more innovative. So it stands to reason that we want to create an environment where we can produce optimal conditions for flow state. So how do we do this? Firstly, we need to make sure that the skill level and the challenge level that is being presented are well balanced. So if we're setting a task for a developer to do, it needs to present enough challenge that their mind is interested, that they're engaged in their learning, but they're not confused or frustrated. Too much challenge can leave you feeling helpless or foolish. And on the other end, if it's too easy, it can make you feel belittled, bored, make you feel like you're being babied. I remember once my dad complained that his computer was broken. And I said to him, like, why don't you just Google the problem? And he said to me, if I were to spend 2 hours, for example, trying to search for a fix for this, I have no certainty that at the end of those 2 hours, I will have a fix or even understand what I've read. But I know that if you spend 2 hours looking at a fix, at the end of it, you're going to come out with a fixed computer. His skill level wasn't up to the challenge of working out what on earth it was that was wrong with his computer, and he found it frustrating. He just gave up before he even tried. And when we're building experiences for developers, we need to consider their skill levels and how we cater for them when we're setting tasks. We want to create confidence in the developer that even if the task is quite complex, they're going to be able to solve it and have an achievement at the end. And getting this level of balance of challenge and skill allows the developer to feel like they're in control of their progress, that, you know, they're the one who is working through getting these outcomes and these achievements. We want to make sure that we are clearly defining tasks, that we're setting achievable goals, and we're helping them feel like they're moving through something. Completing tasks brings a great sense of achievement and reward, and it motivates the developer to strive to learn the next thing or do the next piece of work. And it keeps them in the flow state, reducing their chance of boredom. Conversely, interruptions, distractions, delays all hinder flow state. So anytime a developer struggles to find the information that they need to complete a task, or if they have too many tasks to juggle, they're switching between windows, they can be pushed right out of flow state because the visual information is too much, the cognitive load of trying to find information is too much. It's like shoving a hurdle out in front of a sprinter, and it doesn't even have to be a full hurdle. Sometimes it can just be a tiny little brick, and it's enough to throw somebody off. And then once they're thrown, it takes such a larger amount of energy for them to pick themselves back up and start sprinting again. And switching between tasks or getting lost or frustrated or distracted while searching for information reduces focus and reduces that stimulation of the flow state. Not only that, it can increase anxiety and unpleasant feelings in the developer. Have you ever found yourself doing something like checking your email when you're tired or frustrated with a thing that you can't work out? Because you don't want to face the mental hurdle that you know it's going to take in order to take that first step to start sprinting. Flow state absolutely depends on developers having the autonomy and the opportunities to work on fulfilling challenges. And the best way to find out whether or not you've got the balance correct between the skill and the challenge is to get feedback from developers. Which brings us nicely on to feedback loops. And it feels obvious, but sustaining a meaningful feedback loop between the developer that is using your product and you who are writing your products is central to developer experience. How can we possibly know that we're doing a good job if we're not speaking to the people who are using our products? And feedback allows us to spot mistakes, to learn, to improve, but it also fosters a feeling of visibility and engagement and recognition of performance. So if you're looking to improve your developer experience, you should be aiming to shorten your feedback loops as much as possible. It's imperative that you make giving feedback about your product as easy as it possibly is, so that you don't block developers from telling you what they love and what they hate. You should, of course, also, when you get that feedback, action it in a timely manner. If you're just collecting feedback and doing nothing about it, they're going to stop giving you feedback. You need to let them know that you appreciate the feedback that they're giving, and doing so will allow you to easily spot where developers are struggling, where you've accidentally just thrown that brick out onto the sprinting track, where you've knocked them out of the flow state, and it'll ultimately lead to you building more beloved products and processes. Similarly, we should be looking to provide feedback to developers as they're using our products. So we should have good test coverage that allows them to know when they're doing well or when something is broken. We should enable continuous integration so that they can run their tests while they're working and get feedback without having to, recompile. We can offer steps to complete in a tutorial with a clear indication that they're working through to a finished product at the end with a success. Providing slow to no feedback can leave developers in the dark, it can interrupt them mid-process, and it can lead to an increased cognitive load. And I could really give an entire talk on feedback itself. There's so many things that we can do with feedback and to improve feedback. There's an excellent article by Tim Cochran, who is the technical director of ThoughtWorks, in which he talks about feedback loops and how to implement and measure them. It is linked at the bottom of this slide. Again, I will share the slides out at the end. So that was a general introduction to developer experience, and you can, of course, interpret these for your own products and your own tools. But I'd also like to give some practical takeaways and examples that I think can make a real difference to developer experience. So let's start with the basics first. Let's talk about our code bases. There are some standard hygiene practices that might seem really obvious, and you might be like, Joe, why are you telling me this? But I'm going to just write them out because I've seen some stuff out there in the wild. So let's talk about what makes a good code base. A good code base follows the default language convention of the language that you are working in at the time. Anything that deviates from these standards, however well-intentioned, however clever you think that you're being, is going to cause more cognitive load on the developer. Every change that you make to these standards is going to raise the barrier of entry to the developer who's trying to understand your code base. Also remember, every single tool that you add in, every dependency that you add into your project raises that bar again. It's another thing that they need to understand in order to successfully use your product. You're just shoving more bricks out on the track. You can reduce time spent onboarding by making use of things like containers and code spaces. Containers are lightweight packages which contain all of your application code together with its dependencies, and they create a full developer environment. So the developer who's using your code has a minimal setup. No more need for complicated dependency installation, fears about platform compatibility. GitHub offers code spaces that run your containers in a browser. Like, this could not be easier at the moment. And VS Code has a containers extension which allows you to use a container as your full developer environment. We can be really making it easy for developers to be using our tools. And if you can't use a dev container, you should at least be avoiding global dependencies. So you want to ensure that your project can be easily reproduced by other developers. This is going to help maintain the integrity and the stability of your project across different setups. I'm a Windows user. Sorry, microphone. I'm a Windows user and I fall foul of this all the time. The majority of developers are on Macs. They make lovely setups for their Macs, and then I come along and it doesn't work. If the external dependencies can't be avoided, you can script them. So in the script section of your package.json file, You can define custom scripts that can be executed with npm or yarn, and they will install the global dependencies for you. But again, remember, the commands can differ between Windows and Mac, so make sure you're supporting them both. Your README file plays an absolutely crucial role in your repository. It serves as the initial point of contact with the developers that are using your products. It's your introduction to yourself. It's their introduction to you as the code writer. That's what I'm trying to say. And it helps users to quickly understand what your project's about, why they might need it, whether or not it does what they want. And a well-crafted README is going to enhance the accessibility and the usability of your product. So you really need to be investing time in creating a comprehensive and informative README that will absolutely communicate the value of your project and foster engagement with the developer community. Like, don't forget to tell them how they can get in contact with you. Personally, when I look at a README, these are the things that I want to see. So first up, if the README is long, I really appreciate a table of contents with links to sections. There are generators online if you don't want to write Markdown, which will make your contents for you. There's a VS Code extension that will do this too. You can then start the README with a brief introduction to your project. What's its purpose? What are the goals? What are the features? Then I want to know, how do I actually use this project? So what do I need to run it? What version of Node do I need, for example? How do I build it? How do I run it? Make me some nice npm or yarn commands and provide them to me as code snippets directly in the README. Really hold my hand through this. Like, give me a usage guide, provide me instructions on how to use your project, and explain the main functionalities within your code base. And include code samples. We love code samples. Include usage scenarios. Let me know if your project requires any kind of configuration. Give me an example of what that configuration might look like and how I can configure and customize the project. Specify exact configuration files or variables that need to be set. Give examples with placeholders in. Let me know any constraints, if there are any particular gotchas, any design decisions that you've made that need to be called out. Don't leave me guessing as to why it acts the way that it does. And there are a whole bunch of other things that you can also add to your README, or you can use as separate Markdown files. So guidelines for contribution, both how you'd like contributions and how users can do things like run tests, submit bug reports, how they can propose enhancements, specify your required coding styles, linting rules, testing frameworks, anything that you want your contributors to know. And also provide contact details for how they can get in touch with your team if they need to, be it Slack, Discord, email. And encourage users to reach out with questions, encourage them to ask for help, to give bug reports, or ask how they can get involved. Make sure that you include a code of conduct explaining what behavior you expect from your community and how you're going to handle violations. Clearly state the license under which your project is being distributed and any restrictions of that license. A well-written README really just massively improves the clarity, the usability, the overall quality of your project. It's really something that you cannot half-ass. And good technical writing can make a huge difference to your README and your other documentation, be it a blog post or a wiki or a portal. And technical writing and developer education it's a whole skill in itself. You're basically taking what is a very complex idea and making it accessible and adjustable. And an important component of good technical writing is ensuring that you know who your audience is, what their skill level is, what they want out of your writing, just who's reading this. So consider what level they might be at in the company that they're at. What's their technical expertise? What's their knowledge level? What's their role? What's their responsibility? Are they beginners, intermediate? Are they experts? And once you've identified who your audience is, create a persona for them, and then assign this fictional person a kind of backstory as to why have they found your product? Why are they reading this README? And then you can make sure when you're writing it, you're writing with them in mind. Make sure that you're using simple, direct language to convey your message. Keep a consistent tone of voice, a consistent point of view, use consistent tenses, use consistent nouns. Write low complexity sentences, keep vocabulary low complexity as well, keep your paragraphs short, give frequent examples, focus on readability and accessibility, make sure you use headings, write descriptive link text. Links need to make sense on their own, not just as part of a sentence. And of course, give any images that you have descriptive alt text. Make sure that you're using inclusive language. Think about the ability-specific language that you're using. So instead of read, try see, or instead of instead of see, try read. Instead of have a look at this, try check this out. And don't refer to things as crazy or dumb. Try instead wild or baffling. And obviously, hopefully I don't need to say this here at React Girls, but there's no need for gendered language in your writing. You can use neutral pronouns and swap out words like man hours or manning for work hours or staffing. And avoid using idioms or slang as much as possible, because these will absolutely confuse folks whose first language is not the language that you're writing in. And avoid as much as you can saying that a process is simple or easy, because this can make folks who are new to the subject feel like they're being belittled. You know, you've told me this process is easy and I'm finding it confusing. Maybe I don't belong here. Many of us have really short attention spans these days. I know I do. Big chunks of text, I see it and my eyes kind of slip off it like it's Teflon. So try and make sure you're breaking up big chunks of text with some nice images, some visuals to illustrate the points that you're making. It also really helps with folks who just don't learn by reading. If you've got visuals, diagrams, that kind of thing, it really helps. And finally, consider, as I mentioned earlier, different learning styles. So maybe you could also include some video or some audio. The final thing that I want to talk about today is the code itself. And these are just a few things that I think can make a massive difference to the developer experience of the code that you're writing. Because we spend the majority of our time with code reading it rather than writing it. And I'm sure we've all seen a lot of illegible code bases. When we're writing code that others are going to read, it's really important that we code clearly and that we code with intention. Because you're very likely not going to get a chance to actually speak face-to-face with the developer that's using your code. So they're not going to know what you were thinking when you were writing it. The code has to speak for itself. Your code should be unsurprising to your reader, it should lower the cognitive load as much as possible, and it should allow them to stay in a flow state as they are working through it. So, functions without side effects. Yes. Functions that do one thing and one thing only. Yes. Pure functions are easier to read, they are solely dependent on themselves. They won't affect external states, meaning readers have less head compute. They don't need to keep as many things in their head. Functions with fewer arguments are generally easier to comprehend. It's just easier to read. Again, you're making your reader keep less things in their head. If you can, refactor your functions to make them smaller, reduce the number of arguments. Promises are more readable and more intuitive than nested callbacks. They make it easier to see the linear flow of instructions. They end up with more concise code blocks. They help developers to understand the flow of the asynchronous operations. And this, of course, is going to reduce cognitive load. We've all seen the sort of the promise callback triangle of doom where you're okay, so this, and then that, oh God, I've forgotten what was happening at the top. Like, let's try and use promises. Return early and often. So placing return statements early on in your functions and methods allows you to communicate more clearly the conditions under which the function should exit. So this reduces the need again for excessive nesting, improves the overall clarity of your code. If I can read through and then go, okay, I've got to this point and I've returned, I don't even need to read the rest. Like, cool. Minimizes the time that I'm spending reading your code, minimizes the need for the developer to, again, hold multiple things in their mind simultaneously. Avoid nested ifs, again, another pyramid of shame. If the nesting level increases, the code becomes more difficult to read. It becomes less legible. It's harder to follow the logic that is happening and the intentions behind the conditions of that logic. The pyramid of shame can lead to bugs, it can lead to maintenance issues, and of course, again, it's going to increase cognitive load. Make sure that you're using descriptive language in your naming rather than abbreviations. Longer function names actually make it clearer what the function is doing and can make your code self-commenting. I don't need a comment if you tell me that your function totals the cost and adds tax. Brilliant. The goal of writing clear code is that when you read it, you can understand what the code is doing. You might be tempted to write comments. The problem with comments is that comments are either lies now or they're lies in the future. And I understand that sometimes you've had to commit some kind of cardinal sin in your code and you've put a little comment in there to explain why that's happened with like a to-do, like fix at some point. And sure, that doesn't go amiss, but comments should tell you why the code is doing what it does, not what the code is doing. And I'm going to make a lot of Vim users very angry now. I love long lines. Long lines of code are a tool that we can use to make blocks of code more readable. And I can hear you all gasping like 80-character linting. But let's take a look at an actual example. So hopefully you can sort of see the shape of this, even if you can't see the code. So this is from an SDK that I wrote recently for the Spotify web API. And this is an endpoint that returns artist data. And I think this is well-written code, judging by the tips that I outlined in the previous slide. The classes and the functions are all nicely named. The functions do only one thing. There is a little comment in there which explains an anomaly that a future developer might come across. And yes, the albums function has a lot of parameters. It unfortunately has a lot of different options, but by putting these parameters all into one line, so I don't know if you can see this here, we have albums, a lot of parameters here, but we've put them all in one line rather than dropping them all onto different lines. And the reason why we do this is I'm kind of saying, okay, reader, there's a lot of parameters here. They don't really matter. You don't need to know anything about them right now. Just skip that, go into the function, see what it's actually doing. Then you can go back and see if you need those parameters. Vertical spacing means something. It's lending an importance to the information that you're dropping onto a new line. You're saying, developer, you need to read and process this new line. And if we're dropping, all our parameters onto a new line, I need to suddenly understand what ID string is, what included groups are, what market is, what limit is, what the limit is, what the offset is. Like, I don't need to know all those things in order to understand what the albums function is doing. I don't need to know them yet anyway. New lines lend importance and significance. A line break, to me, suggests a new section of code. So be it a function or a logical block, a new line helps with cognition. Our brains can understand that we have separate bits of code that are doing separate things. So I'm not saying don't use new lines, like I love new lines. Like, it makes it obvious. Where have I got a nice example here? This is too short. Oh, here we go. So, you know, I've got my if statement here. I've got a new line here before I start making some more variables because it's a different chunk of code. It's doing something new. So now let's run my beautiful legible code through a linter and see what it does to it. There we go. When I run this through a linter that is set to 80 characters, I am potentially lending significance to lines of code that are not necessary to comprehend on an initial read through. And I don't know about you, so these two pieces of code are exactly the same. If I look at the first one and I look at the second one brings me out in a cold sweat, to be honest. If I'm sitting down to read this for the first time, it feels like there's so much more to comprehend, even just looking at the shape of it. To me, things like this up here, where we've got all our import types, like, I don't care. I don't care what's being imported here. Why are you making me read all this? Put it all on one line. It kind of feels to me like hitting return in the middle of a sentence. Like, it just doesn't make intentional sense. All of a sudden I need to know, like, what have we got? Artists, market, playlists, like, what is this? It's detailed information that I don't need just yet. It's not relevant to me until I decide which of the functions in here I actually want to use. In the original formatting, the actual important information that we need to care about is on line 5, whereas in this new formatting, it's all the way down here. Like, we're just adding a huge amount of cognitive load onto our developers who are trying to read this for the first time. White space has been removed, so all of that nice new line that I put in, that's gone. What have we got? What else have we got in here? We're declaring functions on a class. These are separate concepts here. So here we've got our class, we're declaring functions on it. I put in a new line, it's been removed. Again, we're sort of squishing blocks together that maybe should be considered separate. The optional parameters that were deliberately on one line have all been moved further down the screen. Suddenly the shape of the function has changed as well. And so now we've got this, we know what a function looks like, right? We've got keyword, name, parenthesis, curly bracket. The shape of it has changed and suddenly it's not quite so obvious that albums is even like, what, curly bracket, parenthesis, hate it. And to add insult to injury, the top tracks return there has been spread over 3 lines. So I don't know if you can see that. Our return here, spread over 3. Why? Just so we could waste an entire line on a parenthesis and a semicolon. Something that had more meaning on the end of the line to which it was connected. All this extra cognitive load that we're adding, we have managed to save ourselves 3 kilobytes. So I'm sure the developer will be very happy that we provided them with this second option. So I'm really sorry, Vim users, ESLint default settings users. This just isn't better, in my humble opinion. This isn't 1996. We have widescreen monitors these days. Let's consider the legibility of our code. Let's consider the intentions that we had when we were writing our code, when we were putting it together, what we were hoping our readers would get out of this. And I guess what I'm trying to say is that my name is Jo Franchetti and I love long lines. Thank you very much.
So this is the Slido link for those people who prefer written text to spoken. But if anyone has got a burning question they want to ask right now, I believe there is a ball, otherwise known as a microphone, but with fur or something on it. A soft microphone, which we can use for the audience. If anyone's got an immediate question. No? If not, then I'll move straight to the Slido ones, because I believe we've got some on there, which are, is always really great to see, basically. For Joe, obviously there's always one straight in there, which is what is your number one README that you've seen? I know I've got a few favorite READMEs. And actually, I want an answer from all of you on this.
You know what? I'm going to say this, and then I know it's changed recently, but the Next and Vercel READMEs are really good and like a brilliant onboarding for someone who had never used Next at all. Like I really loved it, but I know they've also done a huge amount of updating recently that I haven't looked at. So I haven't looked at it in like 9 months, so don't hold me to that. It might be terrible now, but it was great. Let's assume it's still great.
And Elle, do you have a favorite?
My answer was stolen. I was going to say the Next.js one. It is very, very good. Like Joe said, it's really good. If you've never used Next before, it's really easy to understand, and the way that they word it is just really friendly for anyone.
I promise that we're not actually sponsored by a sandwich. And Stephanie, do you have a fave?
I just gave a whole talk about server-side rendering. I was going to say Next.js as well. Yeah, I hate being put on the spot, but
sorry.
Yeah, I mean, there's some great READMEs out there. I just can't think of them right now. I'll get back to you.
I personally really like the React Native ones. That's like how I learned React Native. My first job was in React Native, and I was like, I'm wholly dependent on these docs, and they really, they paid off. So yeah, it was awesome. I don't know if you've enjoyed the recent move towards gamified docs, with like progress bars, the little questions at the end that you get a tick.
Yeah. I mean, I think again we're trying to make sure that we're keeping our developers in that flow state. So like you get that nice little boost after going like, oh, you've completed this, you've completed this, you've completed that, rather than presenting them with this huge wall of text, which, like I said, like I see a wall of text and my eyes just sort of. But if I get a little check every time, I'm like, I'm a winner. This is going to be great.
It's so true. It reminds me of like TDD in general, which I think is perfect for flow state, because you just see green ticks come up, and it doesn't matter how trivial your test is. It doesn't even matter that you're probably going to delete it in favor of a better test maybe later. But those green ticks.
It's them feedback loops again. Quick feedback loops is just essential.
Any other comments on that? Yeah. So I've got another question. Again, the linting rules. I think we were all wondering whether anyone will allow us to have a line that long, basically.
You can fight for it. I believe in you. Like Joe said, actually 80 is too short. I don't know whether I should admit that I don't use it.
Yes, this was my next question.
Ellie's about to fall flat on her face. I just feel like I know that was only one example. I hope you can start to see that the shape of your code implies the intentionality of the code. And, even if you don't stick with an increased past 80 character limit, I hope that the takeaway that I want you to see is how much you can affect what your reader is understanding by the shape of what you are writing. And, if you can't increase your character length, then white space is your friend. So make sure that you're putting lots of nice new lines in so that I can understand, like, this is a block that does a thing. And once I've understood what that block does, I can kind of forget it and move on to the next block. Like, I'm not trying to hold lots of things in my head. Once you start doing that, you will start to see that maybe things can sit on one line, especially things like imports and stuff like that, where you don't want them to have to head compute. You don't want them to have to think about it all the time. And then you can start to argue with the people who have the say in what the character limit is. Try it. Try it and see.
healthy discussion in the workplace is always good. I don't know, but like, so what if you don't have a linter, but everyone else does, and then every time they save one of your documents, you have the world's biggest Git.
Yes, I do. Yes, and I will fully admit that it doesn't. That approach doesn't work if you're working on large projects. You need to make a collaborative decision. A lot of the work that I do is writing tutorials and writing demos, and that's when legibility and understandability, is that a word? Sure, is so important. Like, I don't want someone who's reading my demo to be like, what are all these imports? Like, doesn't matter. They get imported. The bit that you need to understand is, what this function is doing. So especially when you're writing to teach, it's important that you get that shape right. And you can make decisions about what's best for your team, but consider that, I know not many of us are hiring right now, but when you're onboarding new people into your team, it's the same scenario. They need to understand what the code is doing. So legibility, absolutely top priority.
I really think this relates a lot to a lot of things in your talk, Elle, as well, because like usability is not just for the users, it's for us as well.
Yeah, 100%. Like when you open that page that's got all of those imports in right at the top, and you're just like, how on earth am I supposed to work out what this thing does? Or like you open you're reviewing someone's pull request, and half of the Git changes are just like import, and then this big function at the end, and it's like it almost impacts your ability to be able to review that code or to understand, okay, what is the change this person's actually made, and what is just the linter being linter and linting stuff.
Yeah, exactly. Do you have any ways of getting around it in your work?
So what I found actually recently is I've never really thought about this before, but if you split up your Git like commits quite nicely, you can almost impact the way that people can review your code. It's kind of a tangent, but like instead of just seeing that big wall of like, here's 1,000 lines of code that have changed, you can go into each individual commit and be like, oh, this is where I changed this function. And it requires a lot of pre-planning. So if you're kind of fixing something really quickly, it might not be applicable. But if you've got time to spend and time to commit to that, you can kind of help in those ways, and then you can mitigate for the linter coming in and linting stuff for you. Or I always, sometimes in like the lint settings that I have, it tells me about them, but I've already pushed the changes, so then I have to come back. I always have that PR, that commit that's like, oops, the linter. Like, oh, I forgot to remove that thing, or forgot to name that thing correctly. But yeah, the linters can be helpful, but they can also cause problems for sure.
And to add to that, you can have a bunch of, commit hooks and commit rules. So like if somebody has done something egregious, they're not allowed to commit it. They have to change it.
Yeah, we have a linter that's like, no. But go back, make those changes.
Can't even push. Yeah, can't even make it public. Do you have any favourite linting rules or technique for?
Yeah, I mean, like obviously I'm not creating public APIs, but the code that I write is for people in my team. And I want to convey an intention through that code, and so I definitely, that point resonated with me. And when I'm reviewing other people's codes, I don't necessarily care about like, oh, they've not written it exactly the same way that I would have written it. What's important for me is that I can understand what they were trying to do and see that what they've written does that effectively. And being able to format your code in a way that that intention comes across clearly, I can picture that being massively beneficial. I work in a globally remote team, and people will be making changes, and I think having a linter, obviously it just runs and fixes all of the linting errors on commit, and so I don't have to think about it, and that ensures that when I'm looking at a PR that I'm not seeing like a bunch of like white space change, because that is consistent through everybody's PRs. And I think when you're working with a bunch of people, well, you just like that's one less thing to worry about in your cognitive load, is that I know that the linting will just run automatically, so I don't think about it, but now I do think about it, right?
Now we all want to turn it into rock.
Well, yeah, I think the way that I would always like approach working with my team is that like any sort of like technical decision that we make about like, oh, maybe you want to increase the number of characters you can include on the line. I think in a healthy team, you would always be able to have that discussion within your team and make that decision on a team basis rather than it being like dictated to you from like principal staff engineer that you've never met before, right? It's kind of like, well, you should be able to kind of decide the best way to work with your team within your team because no one knows your team, like your colleagues, better than you do.
Yeah, very true, very true. I think developers love talking about the way they work as well. So like, a good opportunity to bring those discussions.
And sometimes it's the quiet person in the team who just has like a really like strong opinion. They're like, oh my god, like, you're just like, wow, I never expected that. But I love that. I love having debates with people and being able to sort of like think about things differently. And when you think about things differently, that's when innovation happens, and that's what we want to encourage, really.
Very true. Yeah, diversity of thought, right? To do should be in caps, by the way. So do you have a set of linting rules that you actually have in public? I guess you don't use the linter, so you don't need them, right?
Yeah, I don't at all. I'm sorry, that's not very helpful of me, but no. I've got an ultra widescreen at home, so like I'm on my life.
Stephanie, I've got a question about the server components. Yeah. Obviously, they're going to be released soon. Mm-hmm. So how can we, in the interim, make sure that we're building single-page applications responsibly and not creating the chunky cat?
Oh, well, I mean, the chunky cat is kind of cute as well, though. No, I think what's important to understand is that like there are trade-offs. I think obviously when we looked at the BBC website before compared to the Dazn website, there was a trade-off in terms of performance, but the benefits were great as well. And I think the way that the web is at the moment, I mean, I'm pretty sure like people in the room don't stop using LinkedIn because they have to wait 3 seconds before the page loads. And so you're able to kind of like make a sort of an informed decision. Obviously, like there'll be some things such as like Moment.js is like a really popular library for data formatting and it's known for being incredibly chunky boy. So there's alternatives that you can use like Day.js or whatever, and kind of like just being able to search and find those alternatives that can help to reduce your bundle size. Obviously things like server-side rendering and frameworks like Next.js and Gatsby can help you to show something to users quicker. React also has some like other cool features that were released in version 18, such as suspense and concurrency, so you're able to show something to the user while asynchronous operations are happening, and you're able to kind of create that, like, as Elle was saying, the illusion of something happening, right? And I think that's what people want to know. I think what's worrying, well, what people don't like about, like, say, slow client-side rendering is that you don't really see anything until all the bundles are downloaded. But if you're able to kind of like show something, like a progress bar or something to let the user know that something is happening, then they're reassured that way. And as Elle said, sometimes if things happen too quickly, then that seems a bit suspicious as well sometimes. There's other like ways as well. Like, obviously, when you run a React application, you'll still have to like download the React bundle and stuff like that. Like you have to do that regardless. But you know, you can make use of features such as like lazy loading within React to make sure that you're not downloading bundles that you don't need. That you download what you need when you need it, rather than downloading it all up front. So there's quite a few strategies that you can use. And yeah, I think obviously if speed is important to your organization, like say if you're doing a real-time trading application, you want to see like the latest stock prices, then you know speed is of the essence. But in most cases, like if you're just like, I mean, if you're Beamery, for example, building something for HR and talent, I don't think shaving off like a second off the performance is going to lose somebody like a job opportunity, for example, in which case, you know, people will be willing to wait to have that rich functionality that's going to be really valuable to them.
Very true. Elle, do you have any ways that you, like, you obviously showed us a few of the skeletons. Do you have any other tricks for just avoiding the general like load time issues?
Something that I like, it's so simple, but I always forget to think about it, is like compress your images. Like you don't need all those kilobytes for that one image on your site. Like go and stick it in a site that will reduce that size. Like small things like that can make a really big difference. And even just like run your site through a page speed tester. Google has free ones. You can see how speedy your pages are, and they even have suggestions to things you can fix it. And I say that as a web engineer. You don't just have to know how to optimize your site. It's not like, oh, you're just supposed to know that. You can go and Google will tell you how you can optimize your site, and you can research that. And there's so many small, tiny improvements that you can make that make those tiny little differences that can like compound together to make a larger difference in making your page as speedy as possible.
Very true. It also helps with like Lighthouse and things for the accessibility. Yeah, it's all just in your dev tools already.
You don't have to just know it in your brain.
Yeah, and I'll add to that as well, that obviously having some sort of observability on your front end, so you're able to sort of like capture information about how real users use your application and how long they're waiting, what devices they're using, what their connection is, or whatever. That's also a really useful source of information. So more about the observability. Yes.
That's true, because there might be times when actually you don't want to be taxing your server with lots of stuff, and instead you know for sure that you've got people with high-end devices, and rather than pushing too much stuff onto your server, you actually need to be offloading some things. Is that something that's come up for you before?
I think it's all about knowing who your users are, really. I think the sort of business that I've been working in mainly most of my career, it will be for internal clients or other businesses. We know that businesses tend to have a good stable internet connection wherever they are in the world. But being able to, if you know that there's going to be users who will have a slower connection, then it makes sense to, let's store information that we've already downloaded and store it in browser storage, so then we can show that to people when they load up and they have something to look at, right? But I think you don't have to over optimize your website too early. Like if you understand your users, then you can make sensible decisions about how much effort is worth putting in to kind of get a good outcome for them, because at the end of the day, it's the user's experience of the website that really matters.
Very true, yeah. Or our experience if we're using the software. And a quick question about the dev advocacy. Like, is that something that you, I think, how do you measure success, not just like in your, as a in DX in general?
The eternal question, the entire of dev advocacy would like to know what success metrics are. I hate to say it, it depends. You need to get to know your audience, you need to know what's important to them, and then you need to build out, these are, so our audience, we've found they're falling off at this page. Like, how do we make sure that they get to the end of the thing? Or our audience wants more of this particular type of content, so we need to make more of that content. Like, it so depends on who your audience is. So the first thing that you need to do is start getting that feedback, reducing feedback cycle time, making sure that you're actioning that feedback so that you learn who your audience is, and then it's making user personas so that you understand each thing that you're doing, whether it's targeted at which different person. It's not just I wrote 1,000 blog posts and got 20 retweets, so therefore success. Sadly.
Close the loop, guys. Close the loop. And speaking of closing the loop, we've got some amazing questions that I can't even ask. So you guys are just all going to have to come to the pub. Because I think our speakers are going to join us there. Is that right?
Oh yeah, absolutely.
Yeah, good. So a few announcements to wrap up briefly. Basically, I'd like you to start off by thanking our incredible speakers for being such a Do you want to be one of them? If so, have a think about your topic. There's a QR code here. I don't know if I've mentioned it already, but you can close the loop by scanning that QR code and submitting your talk idea. So we accept anyone we accept women and girls in this to do the talks, but we accept anyone to join the community, and we encourage you to, women you work with, companies that you think might want to sponsor this. We've got another one coming up before Christmas. So yeah, feel free to get in touch. The QR code will do all the hard work for you. And yeah, we especially want to thank our incredible sponsors today, Monzo, for inviting us to their beautiful. Yeah. Oh yeah, the feedback. We want the user feedback. So on there is also some forms that you can fill in to provide us with feedback, ways that we can improve. So if you want to join us for the pub to actually ask your questions on the topics that we've just been discussing, then please join us at the Horse and Groom, which is on Curtin Road, which is a 1-minute walk from here. So I'm going to leave the address up so you can just Google it now, get the info, and then we are unfortunately going to have to leave here, but please come with me. Oh yeah. One more surprise. Oh my god. Okay, so apparently you've all picked up a small piece of paper. Is that correct? So if you all get out your little pieces of paper now, I can announce the 2 winners of the raffle. So I'm sure will be.
It's just generated.
Great. Okay. So our first random number is. I wish I knew all those bingo numbers. You know, I could be like. Unbelievable. Number 2. No! Stay in there. That is, yeah. I mean, no. You'll get a goodie bag in a moment. Okay, next one. 17. Yay! Sit on the front row, guys. That's the tip for next time. And above all, I'd like to thank you all for coming today. It really means a lot to the community. It means a lot to me for my first hosting of this event. And it definitely means a lot to these wonderful women who helped us do this. Thank you, guys.